Hi everybody. Well, it's another beautiful, bright, sunny day here in Millcreek Township. Wouldn't it be great if we could capture all this sunshine and save it for a rainy day? Well, in a way, that's what we're doing here. The township is about to embark on an exciting new project that will harness all this sunshine and turn it into electricity. It's called solar power. Over the next few months, the township will be planning its own solar farm right here on West 26th Street. 26 state-of-the-art energy-efficient solar panels will be installed right above me on the roof, and another 90 more on a roof of a maintenance garage out back. Not only is this beneficial for the environment, but it's also expected to save Millcreek taxpayers thousands of dollars a year in energy costs. Now, how's that for making a sunny day even brighter? Generating solar energy really is a fascinating process. So join me now as we take a closer look at how solar panels work, how they're installed, and just how much energy and money can be saved by using nature to power the future. Hello, I'm here to see Joe Cuyama.
I believe he's expecting you right through these doors.
Thank you. Hi, Joe. How are you doing today?
Good. Pete, yourself?
Very good, thanks. How did the township come up with the idea of installing solar panels on the township building?
With electric and the deregulation and everything that's going on, I said we really need to start thinking about what we're going to do. You know, the projections were 30% of increase, and that just scared us. In government, you know, where do you get a 30% increase, and where are we going to get the money to do that?
The township applied for a federal energy department grant that would pay for the design and installation of solar panels, as well as other energy-efficient improvements to a second maintenance garage.
They looked at, you know, the population of Millcreek. They looked at the solar panels and the plan that was put together. Great plan with both buildings. And being it was a government building, they thought, okay, we'll see what government can do with the money that we're going to supply to them.
Millcreek was awarded a grant for $491,600. However, federal money has its stipulations.
Every penny of that had to be for product that was made in the United States. Everything had to be made in the United States.
The successful bid for the Millcreek project is a joint venture between Zenith Systems, Keystone Electric, and Solar Revolution, a local solar energy integrator.
We've done more installations here in Erie, Pennsylvania than the largest solar company in Florida. There's incentives in Pennsylvania where there's not in Florida. There's a 30% tax credit for residential. And then there's the Pennsylvania Sunshine Program. That's still huge. You got a huge payoff.
Joe, how much money do you think the township will save in electric bills?
The savings that we're going to be looking at right now is approximately $5,000 to $6,000 a year on electric bills. But the big savings is that when we produce electricity because of the solar panels, when you produce electricity, the electrical companies have to buy what's called green tags. Those green tags then go to the market. It's like the stock market. Who will bid the highest? And anticipated cost right now for buying those green tags from Millcreek is anywhere from $8,000 to $9,000. So there's a big savings right there. With the sun and the daylight, we're looking at between 15 years and 20 years to pay this system off completely, and then a cost savings for the taxpayers with a life expectancy of these panels at 45 years.
This is the future. You know, this reduces pollution. This will reduce dependency on foreign oils and foreign trade. I mean, this will create jobs in the U.S. by having more green jobs.
Richard Goffman is a LEED accredited professional electrical engineer for Keystone Electric's parent company, Zenith Systems. He and fellow professional electrical engineer Dave Wieland designed the Millcreek solar panel project.
Their location geographically was in the right location, and the orientation of the facility, the available roof space that they had, whether it was on the garage or on the main building, it just really lent itself to a good installation.
Well, this project was like a perfect example of what you would want to see in a building. this project lends itself from an engineering standpoint to this installation because how the roof was slanted. The coordination was pretty standard once you got into the building because there was plenty of space for us to work within the building.
A key element in the design phase is to assess the main goal of the project, which is to save the most energy with the amount of funding the township has to work with.
From there, we can start to get a generalized idea of which direction we want to head in, how many arrays do we want to have, what kind of equipment do we want to use, and then we start to refine it from there. Once we get our equipment selected, we can size all of our wiring, and the installation is all done by local codes, by the National Electrical Code, by building codes in the state of Pennsylvania. And that entire project is then documented onto our blueprints, reviewed by the local authority, and we can go ahead and get into our construction mode.
Construction mode begins with Jeff Bartlett, Rich Uhas, and Jim Kibbe from Keystone Electric surveying the site. As the field foreman for this project, it's Rich's job to plan and execute. His first task is to figure out how to get 400 feet of 3/4-inch conduit from the township building's basement to the roof with the least amount of obstacles. Armed with blueprints and a ladder, Rich starts knocking on doors and peeking into every nook and cranny he can get to.
Investigating the job.
No time for coffee or snacks. He's got to find out what he's getting into for the next 3 to 4 months.
Every job's interesting. Each one's its own little surprise.
Installing the conduit begins in the basement. It sure looks like a safe place to start. Rich thinks he's found a path from here to the attic, just below the roof where the solar panels will be installed.
It was a little bit of a congested area, so we wound up finding another area to go through. There was a pipe chase coming from basement to 3rd floor. There was access doors provided on the first floor and ground level floor. On the 2nd floor, we needed to add an access way to get into that pipe chase so we could extend our piping from the ground level floor up to the attic space. Once we got into the attic space, we were able to come across the trusses and come to the area where we're going to be penetrating through.
Running conduit throughout the building involves drilling a few more holes in walls, at the same time being very careful not to damage any nearby police cars. And check out the size of that drill bit.
The one we used to blow through these holes was 1 1/8 size we run through for a 3/4-inch conduit, and that gives us enough room that we can fire seal around it, you know, to meet the code requirements for going through fire-rated walls and that. It's a ride if he gets a hold of you. She'll send you for a loop.
As Rich and Jim connect and extend the conduit pipe across the basement, one thing becomes very apparent. These guys are perfectionists. Every step of the way is carefully measured and meticulously leveled.
I mean, no one wants to look up and see chintzy work left behind. Plus, the straighter it is, the easier it is for pulling your wire when you go through on it, making sure everything's tight. You know, if you have a loose connector or anything or go into a box, sometimes you're pulling wire, and if it's not fastened good, then it'll pull apart.
The crew connects, bends, and tightens 400 feet of pipe that will hold the wire for the solar panels, and another 250 feet of pipe for separate cables that will show a data readout in the lobby. With all the conduit routes in place, the trick now is getting the wire through it.
The next step we're going to wind up doing is we'll suck strings through our pipes and get lengths of what we need a wire to be pulled through. Pretty much we'll use a shop vac and a mouse, put a mouse at one end and a shop vac at the other, and turn it on and suck the string through the pipe. Once we do that, we can pull the string through and get a length of measurement of what we need for multiple cuts passing through. Tie the string onto the wire and put a guy at each end and just pull it through.
After a little cleaning up, no one even knows they were there. Now let's go outside to the maintenance garage where the crew is about to begin the next phase of the project, installing the mounting racks that will support the solar panels on the roof.
We'll be mounting the L-foot and the rail for the panels. The L-foot are mounted with a lag into the roof. Then we come back and we'll seal these up. Once these L feet are attached into the roof properly and sealed, then we'll come by with our rail. And these are in 20-foot sections for this roof. Then we'll come by with the mounting equipment, which will slide into the rails like this. The rails will get mounted into the L-foot, screwed down every 48 inches. The rails are attached with a splice bar. The splice bars come in here. Self-tapping metal screws, and that's how the splice bars at 20-foot sections are connected together. Then once these are up, you got 2 rails per panel. The panels will sit on the rails, and then they're attached down with the end clamps and mid clamps.
The racks on the garage will hold 10 strings of 9 solar panels that are fastened together in stages. One thing that's very important when you're working at high elevations like this is that everybody adheres to the strictest of safety standards. Everyone that works up here on the roof must wear a safety harness with a locking lanyard that's connected to a secure tie-down point.
OSHA has their requirements up over certain heights and certain slopes that you are fastened off and tied off all the time. Being the locations of where we're at, you're trying to look out for the best safety of your guys and everyone around you working. Having the safety harnesses available, it makes sense to use them and have them for the fact that you're going to have so much racking and everything up on the roof that you're going to be walking over and tripping. It's easy to lose your balance up there when you've got that stuff that you're watching out for. You're not paying as much attention to your footing because you're comfortable on that roof, and once you stop paying attention, you tend to lose sight of where you're at, and that's when you start going down.
Once the racking system is complete here on the maintenance garage, it's off to the roof of the main township building. Let's go check it out. Another 26 solar panels will go here on the southeast corner of the building. Although this section will hold fewer solar panels than the maintenance garage, the design of this roof poses some unique challenges.
The difference between the two buildings is the one building is a newer style building. When they had put the trusses on, they went with a engineered truss. The engineered truss is all a metal fabrication that you're only able to fasten to in certain points. And it's all engineered and designed for penetrations. You can't just go and fasten into that truss line. We had a hat channel that ran east and west on it, that we were able to lag through on that and pick up that strength as well as the plywood strength. So we weren't messing with any of the integrity of the structural on the roof trusses.
With Jim on the roof and Rich in the attic underneath, they communicate by cell phone.
All right, Jimmy, go ahead.
There it is.
That is the most beautiful thing I've ever seen. It's perfect. So having a guy up top, following that string line that we had pulled out there, and a guy underneath telling him if he's hitting center or hitting off center, which way he needs to go, was the most accurate way we could get where we needed to be hitting to stay with most strength.
23. right there.
Once the measurements are carefully calculated, the installation process is similar on this roof. Bolting down the mounts, then connecting and attaching the racks. The solar panel racks are all mounted, and after another grueling day in the hot sun, the crew calls it a day. With the break of dawn comes the delivery of the next important components, the converter boxes. These units have the amazing ability to convert the direct current generated from the solar panels to alternating current. One converter box is installed in the municipal building basement and 2 more in the maintenance garage. This installation isn't easy. Each unit weighs nearly 400 pounds. The converter boxes are then tied in to the main electrical panel.
In a normal situation, when you have no other source of energy, your meter's always run in one direction from the utility company. As your photovoltaic or whatever renewable source that you have is producing energy, that meter starts to slow down. You're supplementing what you're getting from the utility company. As that meter slows down, you're not spending as much money on your utility bill, and there's savings associated with that. Now, once you start producing more energy than what you're actually consuming, that meter will stop and actually run backwards, because the surplus energy that you're producing no longer goes to your facility, goes right back out into the electric utility grid. That's where you really get to see some significant savings.
Well, the day everybody is waiting for is finally here. 116 solar panels arrive from a manufacturing plant in Norcross, Georgia. The panels are loaded on a scissor lift, then raised up to the roof and carefully unloaded. Solar energy is also known as photovoltaic, or PV. Solar panels are made up of a series of photovoltaic cells that convert solar radiation into electricity.
The sun releases plenty of radiation. You and I see this radiation with our eyes when in the form of visual light, but it releases gamma and X-ray and UV. And all these different solar radiations can be caught in the semiconductors in a photovoltaic panel. The panels are made up of lots of little cells that capture this power.
The modules are linked together into an array by a series of wires that are plugged together at each panel. The solar panels are also grounded for safety.
The wiring methods that are used there, nothing is exposed. No one can actually physically walk up and get themselves zapped. It doesn't work that way. That's the first thing that you have to think of in whatever application you're doing. The safety is always first. And grounding is one of the very first steps to establish a safe installation. That also allows all the overcurrent protection, whether it's fuses or circuit breakers, to operate properly in the event that something did happen.
Each solar panel is then bolted to the mounting racks. After a few days, the solar panel installation is complete.
When I seen the panels going on and how many were going on that roof, I really started to get excited, because I thought, cha-ching, this is money that's going to be coming back in the Millcreek Township, the residents of Millcreek, and rightfully so.
All of the wiring from the solar panels runs to what are called collector boxes. These units send the direct current from the panels to the converter boxes.
The sunlight shines onto it, obviously, but what it does is the photons that are coming from the sun actually are able to strip an electron away from the material that's in here. That electron is gathered and collected together in series of panels to go back to the collector box, and those electrons, that's electricity, that's current. All gets collected in the box from all the arrays that you have, and eventually gets funneled back into our inverter system that's going to turn that electrical energy, which is DC current, into alternating current, which is what the utility company runs on. Everybody's house runs on AC current, and you're able to use that energy to supplement what you're getting from the utility company.
Once everything is wired, the big moment arrives, and it's time to flip the switch.
4, 3, 2, 1.
The savings were noticed immediately.
The first 2 days that they were in operation, we were able to run our garage number 1 and this main building free. We paid nothing those 2 days. They were beautiful days, but we paid absolutely nothing for electricity.
A portion of the grant money is going toward public education. The township sponsored a series of 6 renewable energy workshops.
There were several components to this. It was very interactive. People were able to get their questions answered, and in one of them, they were able to build a little solar car and a mini wind turbine. And you actually got to see those run with the use of a sun lamp, and then they also had like a fan for the wind, so that you got a chance to see on a smaller scale, much smaller scale, as to how things are put together.
Many of the educational areas have been videotaped. These are going to be available to the general public. Anybody can come in and either sign out or just take one of the videos, especially, for instance, like the residential. If you're interested in putting solar panels on your home, what all would be involved? You don't have time to take the workshop, nor did you take the workshop. Well, we videotaped that, so you would be able to take that out.
The township is also purchasing several children's books promoting renewable energy that will be available in Millcreek Elementary School libraries.
It gets that age group excited about it. So when they get excited about it, they go home and they get mom and dad excited about it too. So that's how we spread the word.
You can also pick up one of these brochures that answer frequently asked questions.
And these are geared towards residential and small business owners, and they have specifically for wind, and then solar, and then energy efficiency. And again, there are many resources made available on those pages for people that want to take it a step further.
You can also see for yourself just how much energy the township is creating.
What we did is we decided to place a monitor right in the lobby of the municipal building, so anybody can come in at any time and take a look at the monitor. It's an actual live feed of the energy output from the solar panels.
You know, it's not about today, it's not about tomorrow. What is going to happen 20 years from now at Millcreek Township when all of us that are here now are gone? Will they be able to take that money and use it for cost-saving projects that they're going to need? Absolutely. Will it last? I hope that when I'm retired and gone, I can read about Millcreek Township and the solar panels that are still working here.
So there you have it. Millcreek Township has officially gone green with its first venture toward energy independence. A big step that will hopefully continue to pay off for generations to come.